Imagine our solar system as a cosmic neighborhood, with the sun at the center and planets like Earth and Jupiter as familiar neighbors. But sometimes, a stranger from a distant star system wanders in, an interstellar object, a true cosmic traveler. These rare visitors have journeyed for millions, even billions, of years through the vast emptiness between stars. Most objects we see in the night sky belong to our solar system, but an interstellar comet is different. It was born around another star, far away. Kicked out by a gravitational tug-of-war, it drifts alone through the galaxy until, by chance, it passes through our solar system. Finding one is like discovering a message in a bottle from an unknown world. Since we can't travel to other stars, these objects are our only physical samples from beyond. When astronomers spot something moving too fast to be trapped by the sun's gravity, they know it's a visitor just passing through. Each one is a puzzle and a chance to learn about the building blocks of other planetary systems. Our latest visitor, a comet named 3I Atlas, has brought a fascinating mystery that has scientists buzzing. Let's dive into the story of this cosmic tourist. How do you spot a tiny, fast-moving object in the vastness of space? With powerful telescopes and a bit of luck. In early 2025, Hawaii's Atlas survey system detected a faint speck of light moving against the stars. At first, it looked like a typical asteroid or comet, but its path was hyperbolic, moving too fast for the sun to capture. That was the giveaway. 3I Atlas was from interstellar space, only the third such object ever confirmed. The discovery electrified astronomers worldwide, who scrambled to observe it before it disappeared forever. Unlike previous interstellar visitors, Atlas was spotted early, giving scientists precious time to study it as it approached the sun. Would it behave like a normal comet, or surprise us? Every observation became a race against time to unlock its secrets. The discovery marked the start of a new cosmic detective story, with clues that had traveled across light years. What would this visitor reveal about worlds beyond our own? 3I Atlas immediately stood out for its unusual path, almost perfectly aligned with the flat plane where our planets orbit. The odds of an interstellar object lining up so closely are tiny, making this a remarkable coincidence, or perhaps a clue. As it neared the sun, Atlas became an active comet, releasing gas and dust to form a coma and faint tail. Strangely, this activity began while it was still far from the sun, where it should have been too cold for water ice to vaporize. Why was it so active so early? Its surface seemed unusually volatile. Scientists estimated up to 20% of its surface was releasing gas, much higher than typical comets. Perhaps as a first-time visitor to any star, its surface was pristine, covered in ices that vaporize with just a little warmth. It was like an untouched snowball suddenly exposed to sunlight, melting rapidly. This early, intense activity hinted that Atlas was made of something very different from our local comets. The mystery deepened. What was driving this cosmic snowball's wild behavior? The big question, is 3I Atlas carrying water, the ingredient essential for life? In late 2025, a team using NASA's Swift Observatory announced they'd detected the chemical signature of water, specifically hydroxyl, a fragment created when sunlight breaks apart water molecules. If true, this would be the first direct detection of water on an interstellar comet. The team estimated the comet was losing water at a staggering 40 kilograms per second, even far from the sun. But not everyone was convinced. Some scientists argued the signal was faint and could be misinterpreted. Was it really water, or just noise in the data? The debate was on, was Atlas a water-rich comet from another star, or something else entirely? The answer could change our understanding of how common water is in the galaxy. The team supporting the water discovery used Swift's ultraviolet vision to hunt for hydroxyl, the ghostly trace of water vapor. Their data, published in September 2025, showed a faint but convincing signal. The calculated water loss, 40 kilograms per second, was extraordinary, suggesting Atlas was far more active than most comets. The researchers proposed that its untouched fluffy surface was sublimating rapidly, like a fresh snowball melting in the sun. Curiously, they found little to no cyanogen, a common comet chemical, hinting at a unique composition. This made Atlas seem even more alien, a sample from a planetary system very different from our own. If confirmed, it would mean water-rich comets might be common in other star systems. But the lack of other chemicals raised new questions about how and where Atlas formed. Was this truly a cosmic fire hose of water, or was something else at play? The evidence was tantalizing, but the mystery was far from solved. Enter the skeptics, led by Professor Avi Loeb, urging caution. They argued the hydroxyl signal was barely above background noise, making detection tricky and dependent on assumptions. Change those assumptions, and the evidence for water could vanish. Confirmation bias, expecting to find water because most comets have it, might have influenced interpretations. The skeptics suggested other ices, like carbon monoxide or nitrogen, could be driving the activity instead. Their message: don't jump to conclusions. More data is needed. This scientific back and forth is healthy, pushing for stronger evidence before rewriting the textbooks. The true nature of Atlas's activity remained an open question. Only more powerful telescopes could settle the debate. 3I Atlas is the third member of a very exclusive club of interstellar visitors. The first, Oumuamua, discovered in 2017, was a mysterious, dry, cigar or pancake-shaped object with no comet-like features, yet it accelerated away from the Sun in a way we still don't fully understand. The second, 2I Borisov, arrived in 2019 and looked like a classic comet, but with an unusually high amount of carbon monoxide, suggesting it formed in a very cold place. Now, 3I Atlas seems to be the middle child, an active comet, but with a unique chemical fingerprint, possibly rich in water, but lacking other common comet chemicals. Each visitor has been completely unique, showing us the incredible diversity of objects formed around other stars. If all three had been the same, we might assume all planetary systems are alike. Instead, we see a rocky enigma, a carbon monoxide-rich comet, and now a potentially water-rich, cyanogen-poor comet. It's like getting postcards from three alien worlds, each with a different landscape. This diversity is reshaping our understanding of how planetary systems form. The galaxy is far more varied than we ever imagined. Studying these visitors is like piecing together a cosmic family album. Each one expands our view of what's possible in the universe. And with every new arrival, the story gets stranger and more exciting. Why does water on an interstellar comet matter so much? Water is the foundation of life on Earth, and many scientists think comets delivered it to our young planet. If comets from other star systems also carry water, it suggests the ingredients for life are common across the galaxy. This would mean countless other worlds might have the right conditions for life to begin. The type of water matters too. By measuring the ratio of normal to heavy hydrogen, we can compare it to Earth's oceans. A match would support the idea that comets seeded our planet with water. Even as the debate continues, Atlas's unique chemistry is already changing our understanding of planetary formation. Each interstellar visitor gives us a snapshot of its home system's chemistry. By collecting more of these cosmic samples, we can piece together the story of how worlds like ours are born. The story of 3I Atlas isn't over. Some of the most exciting discoveries are still ahead. After its closest approach to the Sun in October 2025, scientists watched for dramatic changes, jets of gas, shifts in its path, and new clues about its makeup. The James Webb Space Telescope has now turned its powerful gaze on Atlas, offering our best chance yet to settle the water debate. Data from JWST, expected soon, could confirm water's presence, or reveal something entirely unexpected. Other spacecraft, like ESA's Mars orbiters and JUICE, are also joining the hunt. This global effort shows just how important this visitor is to science. Each new observation adds a piece to the puzzle, helping us understand not just Atlas, but the galaxy itself. Interstellar objects like Atlas inspire us to build better telescopes and ask bigger questions. As Atlas continues its journey into the void, the knowledge it leaves behind will shape the next generation of discovery. The universe is full of surprises, and we're just beginning to uncover them.